All right, so when we start working with fractions, there are lots of little things we have to pay attention to, from how we understand them, to how we simplify them, to how we work with them mathematically. And working with fractions is something that you can do better, you can become better at by practicing. So let's talk about some key ideas with fractions. Now, of course, when we talk about fractions, we can look at a few fractions and just think about them for a second. When we write a fraction, one way to view it is as a division problem. So for instance, 4/4 can be thought of as 4 divided by 4, and of course we know that that is the same as 1. 9/3 can be thought of as 9 divided by 3, which is 3. Alright, we have other fractions. 5/1 can be thought of as 5 divided by 1, which is 5. So it would make more sense for us to take each of these fractions, and rather than leave them as 4/4 or 9/3 and 5/1, to rewrite them as the simpler 1, 3, or 5. We try to do this with fractions. We always try to write them in their simplest form. Now we have a couple tricky ones to watch out for, and they both involve 0. The first one might look something like this: a fraction where 0 is in the numerator, 0/3. If we think about this as a division problem, 0 divided by 3, it might help us to understand that the answer is 0. 0 divided by 3, how many times does 3 go into 0? The answer is 0. So anytime you have a fraction with a 0 in the numerator and a non-zero number in the denominator, the answer is 0. But if we flip that around and put the 0 in the denominator, then we have a bit of a problem. We get something that is undefined. Doesn't make sense mathematically. 5 divided by 0 is not a mathematical quantity, so we've got to remember that. So those two you want to keep in mind. 0 on top of a fraction is okay. 0 on the bottom of the fraction is undefined. A lot of students get those mixed up and get into trouble. So that's the first thing that we want to just make mention of, is that we can think of these things as division. Now the second thing that we think about with fractions is the idea that if I give you a fraction, say I give you 1/4, as a fraction that can be written a lot of different ways, and we know we can write it as this. It's the same as 2/8. It's equal to 2/8. Mathematically, those are the same two numbers. You can see that if you think about taking something that is 1 unit long. Let's write out 2 of these, and if I divide it first into fourths, like the first fraction suggests, 1/4 is exactly that much, right? And you've seen this before. If I divide it into eighths, again, it's still the same length object, but if I divide it into eighths, there they are. They're littler pieces, but now I'm taking 2 of them. When I take 2 of them, that's the same as if I were to take 1/4. And so fractions can be written, the same fraction can be written in many different forms. 1/4 is the same as 2/8. It's also the same as 3/12, 4/16, and you might see how I'm getting these. For instance, the next one I can get by taking 1/4 and multiplying the numerator and the denominator by 5, and I get 5/20. And this list could go on forever. All of these fractions are the same. Now here's a couple facts to remember. Number one, when we give a final answer or when we report something, most often we're going to want to report that version, the simplest, the smallest version, the version where we've eliminated common factors. Okay, so our final answers we'll always, we'll always try to put them in reduced or simplified form. But as we work mathematically with these things, sometimes it's better for me to work with the 3/12ths version. Or, in a different situation, it might be better for me to work with the 5/20ths version. Notice, in either case, I'm still working with 1/4, but I'm just working with a different version of it to do the math and the calculations. And then at the very end, I'll want to report the simplified version. So a lot of times these versions of a fraction are the ones that we work with to do our arithmetic, but we'll report our answer in the simplest version. Now we could have this discussion about any fraction out there, and so we want to remember that all of your fractions can be expressed in a variety of ways. Now, one common kind of question you'll see with fractions is this: simplify, and as an example we might simplify the fraction 20/35. Alright, now you probably already have some methods for simplifying this, and you've probably already got it simplified, but I want you to see to take a step back and think about the actual process of simplifying a fraction. So 20/35, when you first learn how to simplify a fraction, and you may remember this, you may not, when you first learned how to do it, usually the method involves finding the prime factorization of the 20 and the 35. There's that idea of prime factorization again. Remember, the prime factorization breaks a number down into its kind of most basic building blocks. And so the first part of simplifying would be to find the prime factorization of our numbers. So of course 20 factors into 2 times 2 times 5, and 30 factors into, or 35 factors into 5 times 7. Those are the prime factorizations. Now what we learn is, in the process of simplifying, once you put each number in its prime factored form, then what you can do is you can cancel any factor that shows up on the top and on the bottom. Basically, if a factor like 5 in this case shows up on the top and the bottom, what we're saying there is that both numbers 20 and 35 are divisible by 5. So let's divide them both by 5. That's what's happening when we cancel. And when we do that, what's left is of course a 2 times 2 on top and a 7 on the bottom, or a 4/7. And there's no other common factors, right? 5 was the only common factor. So this is the simplest version of this. Okay, we've simplified it. If I were to make a list like this, based on 4/7, it would of course look like this, right? My first and simplest number would be 4/7. That equals 8/14. That equals 12/21. That equals 16/28 equals 20/35. Look at that, there's our number, and we could continue that list, but notice there's our two numbers. This is the more complicated version of this simplified version, and that's what we want to do. So there are the first three principles that you kind of want to make sure you understand when it comes to fractions. You've got to be able to understand what they mean and be real careful about dividing by 0. And then you need to basically understand that each fraction can be expressed in a number of different ways. And then finally we need to understand that we can simplify fractions, and we want to simplify them as we get ready to present them as our final answers. And so when we're working with them, we often work with the more complicated versions when we add them, for instance, but in our final answers we always want to provide the simplified version.